My name is Robin Barron, and this is my presentation on algae. In the early 2000s, a lot of major energy companies began investing in algae because of a lot of reasons included here. How algae is made into fuel. Algae is a single-celled organism that uses photosynthesis to create oils from the sun's energy, CO2, water, from the atmosphere. A lot of it can grow in saltwater, which means that we can preserve a lot of the valuable freshwater resources that is needed for other things, such as drinking water. Algae is grown in either open pond systems or closed systems, and these allow engineers to regulate growth conditions more precisely in order to make it more effective in growing it for biofuel. This vegetable oil is harvested and converted through industrial processes into biodiesel or renewable diesel and jet fuel. This biodiesel can be made through a relatively simple conversion process, whereas the renewable diesel and renewable jet fuel are made through complex refining processes that involve a reaction with hydrogen. This vegetable oil is extracted from a biomass that also comes with it. This diagram kind of shows the process that they go through in order to make this biofuel. First, they have to go through the strain development, which includes genetics and breeding. The inputs include CO2, water, nutrients such as nitrogen, and sunlight. The production, they focus a lot on pond design, water management, and crop production. Then they move on to harvesting, which includes dewatering the algae, and then they make the co-products, and they have to extract this fuel from the biomass. The biomass is used for things such as animal feed, anaerobic digestion for methane or natural gas, and or nutrient recycling. So this fuel or oil is refined then in order to make diesel or jet fuel. A lot of the challenges are listed below, such as strain isolation, nutrient sourcing is difficult and costly. Harvesting and extraction is very difficult in high percentages. Co-product development, they need to find more efficient uses for this biomass that is created. And refining is very costly. The latest estimate shows that it was coming out to be $10.5 per gallon, which is very, very much higher than petroleum diesel, what we use mostly today. By the date of March of 2023, ExxonMobil, BP, Shell, and Chevron had all backed out of algae fuel production, sadly. A large reason why this was looked into, because it has a lot of pros, including a low carbon footprint. Algae actually can absorb 50% of the CO2 in the atmosphere. So this is 30 to 50 billion metric tons of CO2 in the atmosphere are converted into organic carbon each year, which is substantial towards decreasing climate change. Another reason why it is very efficient is that it would create 30 times the energy yield from algae than what we currently use in land-based crops. This statistic is from the Department of Energy. Lastly, when comparing the greenhouse gas emissions from petroleum diesel, what we mostly use today, and diesel from algae is only 40% of what petroleum diesel releases when it comes to greenhouse gases. The economic impact that algae has had is that actually right now, there are no significant biofuels produced from algae currently. The U.S. Energy Information Administration reported no biodiesel from algae feedstocks from 2018 to 2020. But on the bright side, a lot of spending on research, such as ExxonMobil spent $350 million over 12 years to research algae biofuels, which means it could move forward in the future. Some advertisement that ExxonMobil specifically did, and is almost the only one that really did, was that they published a commercial on Facebook, Twitter, and YouTube in 2019. But other than that, mostly it's just small articles from small newspaper outlets that are reporting on algae. In this commercial, they state algae, its potential just keeps growing. Sorry. And then my current analysis on the situation is that algae holds great potential, but sadly, we need the resources and the funding to continue the research needed for it, which requires a lot of giving that. Anyways, and then so my plan of action moving forward would be to somehow boost research. Specifically, we could use incentives, maybe from the government, however, and then the next step would be to target the research towards a lot of the challenges that I listed earlier, such as genetic contamination of the algae. And then next, we could build a government pilot plant in the desert with a saline aquifer to really boost and get this started. And then lastly, we would need to get the commercial plants involved in order to further increase the production of this, as well as the use by everyone else. That was my presentation, and these are my sources. Thank you for listening.